So it's time to unveil more mysteries to you in the HPLC world. And today we're going to talk about some more specifics of your stationary phase, and that is things like the surface area and the carbon load. So if you've never heard those terms, this is a really important talk because this will give you some of the specifics, what makes one C18 column different than another. So let me help you define these terms. Most people know if they're using a C18 or a C8, but they may know their particle size. I hope they know the 5 micron, 3.5 micron, 3 micron particle. But what they probably don't know is the specifics like the carbon load and the surface area. So let's talk about them. So carbon load. It's literally a gravimetric analysis. We take your stationary phase, you take 1 gram of stationary phase, you weigh it, put it in a muffle furnace, take it to 800 degrees Celsius, burn off all the C18s, weigh it again. What's the percent difference? That is carbon load. So we're going to burn the carbon off the column, and that's how we would measure it. So C18 columns, you would think they'd all be the same, but bonding density is different. So I'll just give you examples in my past. I think so most C18s are going to be 15 to 18% carbon load. That's probably where you're going to be. Now, I remember I believe it's a Waters Nova pack that had a 7% carbon load. That's the lowest one that I remember, C18 down at 7%. And then Phenomenex used to make a column called the Ultra Carb, and it was 30% carbon. So they were both C18, so you imagine we range from 7 to 30%, but most columns are going to be, probably on the market day, you'll see the 12% up to the 18%. In general, so now let's talk about, now you know what it means, but what does it mean to me as a chromatographer? Why should I care about the carbon load? The higher percentage carbon load, the more nonpolar the column is, the more molecules it can hold on to. So if you needed to inject a large amount of material, if you wanted to overload a typical column, the column capacity is a function of its capacity factor, so how well retained the molecule is. So if you have a higher carbon load, if we have the 18% carbon load, things are going to be retained longer, which means we could hold on to more molecules and we're not going to overload the column as easily. So prep scale, we love to use high carbon loads for that reason. We can overload the column, for most people, for a high carbon load would be fine. End cap columns tend to be in that 16, 17, 18% range because end capping means not only do we have the C18s, but we bond some carbon to the little silanols as well. So I think carbon load, if you have never heard of this term, you can probably live a full and happy life and not have missed anything. But to me, knowing the carbon load, when you look at columns, now you could look at a little more specifics like, wait a minute, if we go to a lower carbon load, things are going to come off a little earlier, and maybe that's advantageous if you have a really non-polar material that you're analyzing. So carbon load, I think, is useful because it really is one of the finer details that we talk about in HPLC columns. Along with carbon load, I would put our surface area. So surface area, first of all, it's an amazing number. If we look at typical HPLC silica, we're talking about like 100 square meters per gram. That means 1 gram of material has 1,000 square feet. Now, some of the material in the MacMod world, we're looking at over 300 square meters per gram. We're talking like a 3,000 square foot, like the size of a giant home inside of the column that you're buying. Why is that impressive? Why do we care about high surface area? Well, where does the separation occur? It occurs on the surface. So the more surface we have, the more separation we could do, the more interaction we could do with the molecules. We also like high surface area because more surface, more C18s, more capacity. Hey, remember that term when we were talking about percent load? So in this case, higher surface area means you could load more material on your column and not overload it as easily. Column overload means, I always say a column should get taller the more you inject. So 1 ppm, 10 ppm, 100, 1,000 ppm, the peak gets taller and taller, but it does not get wider. Peak width at half height is a constant. That's true up to a point. And at some point, the peak will start to grow broader, and that is the capacity limit of the column. That's where we run into that overloading the column. Now, it doesn't hurt the column to overload it. You don't damage it, but the chromatography changes. You shift peak retention times. So we like a high surface area material because it's not easily overloaded. It's not likely for your retention times to change even if you inject a huge amount of material. It's also advantageous for prep scale. So those are the specifics, what I like to call the specifics of the HPLC column world, where we're talking about percent load and the surface area. And knowing about them can really help you fine tune or find just the right column, especially for those unique situations. Yeah, there's something more nuanced, and that's why I'm a big fan of carbon load, because I've used it in the past for just that example, overloading a column. But some people will argue, well, it may be more of a function of bonding density. If you bond a C18 onto a column, we have a normal silica, SiO, SiO, SiO silica. We put a C18 here, C18 here. Generally speaking, we can't put one in between. There's no room there. So if you do C18 chemistry, the traditional approach, you only bond half the silanol. So you literally only have C18s. If you can figure out how to improve that, if you can figure out how to go to those silanols in between, bidentate, where you have it grabs here and it grabs there, or lots of T-butyl groups in the middle. So there are ways to put more carbon on the column other than just surface area. So it's not a one-to-one, but I think those are both important parameters that I like to look at, because if I'm getting if I'm looking at a 10% carbon load material, which would be like a C8 or maybe even a C4 material, I know I'm going to get a lot less retention. I'm going to expect things to shift in that scenario. By the way, it's not always better to have higher carbon load and higher surface area. There are times where, just that example, a really, really nonpolar material, an analyte that's, a silanosol, a C45 hydrocarbon, yeah, you really don't want a lot of carbon, because the more carbon, the more retention, and it's hard to get those things off the column. So if you have more questions on specific things about HPLC, send them on in, and we're happy to give you some answers.